Greenhouse gases stored in the sediments of lake beds are released more easily into the atmosphere if the lake is salty and shallow. And like polar ice, lakes also hold a record of how climate has evolved over time. Lakes are thus responding to and regulating current changes in climate, for which they serve as an indicator. Today we are seeing rising temperatures, shifting precipitation patterns, shrinking ice extent, and big variations in water levels. For example, over the course of the last century, the surface temperature of the Great Lakes in the US rose 3.5 degrees Celsius. And that of Lake Issyk Kul in winter has risen over 3 degrees Celsius in the last 60 years. Different disciplines provide different perspectives on such changes by observing parameters like surface temperature, storage variations, water quality, or biochemical properties. Numerous current and planned space missions will serve applications in this area. But SWOT is of course attracting all the attention as the first satellite designed specifically to study land surface waters. SWOT will regularly survey the extent, height, and water storage variations of several million lakes around the globe. But alongside SWOT, a multidisciplinary approach will probably be needed to factor in all of the parameters governing how a lake and the water cycle work. Like the snow and ice melt, rain, rivers and groundwater that feed a lake, as well as losses like evaporation, and abstraction for crops and cities. All of these parameters also affect lake levels, and measuring them will make it easier to identify the effects of climate change on lakes and their role in Earth's water cycle.